Okay, we're ready for lesson 14 of module 2, more on the angles of a triangle. In this lesson, we're going to look at a third proof of the angle sum theorem for triangles, and that's that the interior angles of a triangle add up to 180 degrees. We saw two proofs for that in lesson 13. We're going to see a slightly different one now. And we're also going to look at some angle relationships in triangles dealing with exterior angles. We've been talking about the interior angles of a triangle, and we're going to extend that. So let's first look at this proof of the angle sum theorem. Okay, so this proof is not in your notes, so you can take notes on a blank page there that you have. So I'm going to start with a quadrilateral. This proof starts with a quadrilateral, and what we know about quadrilaterals is that they have, and actually this is a rectangle, 4 90-degree angles. So each of these is 90 degrees. So this these angles add up to 360 in this quadrilateral. And so what I'm going to do is I'm going to construct a diagonal here on my quadrilateral, right like that, dividing it into two triangles. So you might want to pause the video and think, what do we know about these triangles and how do we know it? So think about that, and then we'll discuss it. Okay, so you may have noticed that these triangles are congruent, and one way we could think about this is by showing the angles to be similar, or to be congruent. So if you look at this diagonal, you could think of this as a transversal because these two lines here are parallel, cut by this transversal right here. So, so what would we know if I look at this angle right here? Maybe I'll call this angle A. Can you find an angle in the bottom triangle that is congruent to that angle? And what you'll notice is that this angle right down here, we'll call it A prime, would be congruent because those are alternate interior angles. And this angle here, let me change colors. This angle right here, we'll call that one B, would be congruent to this angle down here, or right over here, because they're also alternate interior angles. So we'll just call that one B prime. So, and then obviously the two 90-degree angles are congruent to one another. So we could map one of these triangles onto the other. And so simply, if the sum of the quadrilateral is 360 degrees, then each triangle has half of those, or 180 degrees. So another informal proof of the angle sum theorem. Okay, now we're going to look at a diagram similar to the one you have in your classwork and talk about some vocabulary related to that. Okay, so look at this diagram here. It's labeled differently than the one you have in your exercises. So just follow along with me. Right now we're going to jot down some vocabulary and work through some relationships here. So we have, you know about the interior angles of this triangle. They are here and here and here. And they add up to 180 degrees. So we're just going to record that down here. So we need to name these angles. So we've got angle CAB plus angle, so that's this one here, CAB. We've got angle AC CB, and we've got angle CBA. Or ABC. But those add up to 180 degrees together. The other thing we have here is this straight angle right along this line. We'll call that our straight angle. So, and that is composed of two different angles here. It's composed of this one and this one. So this angle is our, we called it CBA right here. We've got CBA. So we've got angle CBA plus angle CBD, which is this one here, CBD, also equals 180 degrees. So we can do something with that and notice this. Let's see if this works for me here. I'm going to erase what I have and rewrite it so you can keep writing on your notes. No, it got rid of my picture, so let's bring that back. Okay, so what you have is, since this amount here on the left side of the equal sign is 180, and this amount is 180, we know that those two are equal to one another. So what we're going to do here is notice that, get a different color, is that we've got this measure of angle CBA on both sides of our equation. So we can get rid of that. And that's this angle right here, CBA. And so what we find is that the measures of angle CAB plus angle ACB is equal to angle CBD. So let's look at where those are. So angle CAB is this one, angle ACB is this one, and angle CBD is this exterior angle. Okay, so we've got names for CAB here and here. If we're talking about this exterior angle, then we're going to call these two remote interior angles. Okay, so if I want to talk about this exterior angle right here, then these two are the remote interior angles. They're remote because they're far away. They're not touching. This one would be an interior angle that's right next to that exterior angle. Okay, so if I want to talk about this exterior angle, think about where the remote angles for this exterior angle would be. They would be these two over here. And I have a third exterior angle right down here, and the remote angles for it would be those two angles. So it's whichever two are not right next to it. Okay, so if I have a diagram and I want to find the measure of this angle, and I know these two, all I have to do is add these two together, and they're going to equal that angle. And it's pretty intuitive to see why that's true. And it's just because the straight angle adds up to 180, and so does the entire triangle. So these two angles are going to be, since all three have to add to 180, you can see why those two angles would be equal. Okay, enough of that. Let's look at your exercise now. Okay, here is your first page of classwork for lesson 14, exercises 1 through 4. So what we're going to do is use this diagram here and the labeling on it, and I'm going to have you just work through at least exercises 1 through 3, and then we'll check those, and then exercise 4 you can do after that. So work on exercises 1 through 3 and then come back and check your work. All right, so here are some sample answers for these first 3. You're supposed to name the exterior angles in each of these. So you could have these in any order, 1, 2, and 3, because it just depends on which exterior angle you chose first. So once again, I'll just go over for number 1. I chose for my number 1 exterior angle RXY, which is right here. RXY is this exterior angle. So the related remote interior angles would be XZY and then ZYX. So these two here. Okay, and then the other 2 examples. So you can check your work. You can always name these angles differently, because remember, angle, you know, for instance, angle, let's see, angle XZY is the same angle as, I could also name this one YZX. Okay, remember, we just need to have the vertex in the middle, and then points on those rays coming off of it. So these are the same angle. So check your own work and make sure that you got those in the right place. Okay. Exercise 4 asks you just to work through the reasoning that I just did in the example as to why the sum or the measure of an exterior angle is equal to the sum of the related remote interior angles. So just take one of your examples in 1, 2, and 3 of an exterior angle and the remote interior and show why this would be true in exercise 4. So you can go ahead and pause. I'm going to get a blank screen to do this, and you can double check your reasoning against mine. Okay, so pause the video now, work through that, and then check it against the video. Okay, so here's a sample for number 4. It's going to vary depending on which angles you chose to focus on, which exterior angle you chose to focus on. So the one I chose to focus on is angle, get a different color here, is angle RXY. That's my exterior angle of the triangle. And so I wrote this equation, or this relationship, that if I take RXY plus ZXY, that's a straight angle, and it equals 180 degrees. And then these are just the angles here of the triangle. Those add up to 180 degrees by the triangle sum theorem. And so since both of these quantities, this one and this one, equal 180, I can set them equal to each other, because I know that 180 equals 180 right here. So what I'm going to do here then is notice that on both sides of this equation I have a ZXY. And whatever that measure is, I don't know what the measure is, but it's the same. So I can subtract that from both sides of this equation and come up with the final relationship that angle RXY is equal to angle XZY plus angle XYZ. These are the remote interior angles, and this is the exterior angle. Okay, so that's an informal proof. It's more than just believing that it's true and using it, we've actually shown it to be true. So check your work. You're going to have different letters here probably, but just make sure the logic is the same. Okay, now look at example 1. You are asked to find the measure of angle x. So go ahead and do that now on your own, and then check your work against mine. Okay, you should have found that the measure of angle x is equal to 44 degrees. And you may have done that by just saying, all I have to do is add the remote interior angles to this exterior angle x to find that sum. And kind of an informal argument that proves you're correct is if we found the measure of angle ABC, we would know that that is 180 minus the 44, or 136, and then the measure of angle x would have to be 180 minus 136, which again would be 44 degrees. So because angle x and angle ABC make up a straight angle or 180 degrees. So we've kind of cut out this whole step by knowing that I can just add these two together to get this exterior angle. We've cut out kind of all this math of having to find first this angle, then that angle. We don't need to do all that work. So okay, let's look at example 2. Okay, so work on this one and then come back and check your answer. All right, so the measure of angle x in this example is 76. It's the sum of the remote interior angles here and here. The measure of this angle right here, angle ACB, would be 180 minus 76, which would be 104, right? So this angle would be 104 degrees, and this would be supplementary to that, minus 180, so it would have to be, this one would have to be the 76 degrees for this straight angle to add up to 180. Okay, let's go on to example 3. Notice that this example is a little different than the other two examples, but again, you have an unknown angle that you're asked to find. But always pay attention to what the diagram is telling you. So go ahead and pause the video and find the measure of angle x. Okay, so in this situation, we're not given the remote interior angles. We're given the interior angle right next to it. So here's a straight angle. So these two here must add up to 180. So the measure of angle x is going to be 180 minus 121 degrees. So the measure of angle x here is 59 degrees. All right, let's look at the next example, example 4. Okay, so this is it. So look at it, study it, pause the video, and come back and we'll talk about what the measure of angle x is here. And always pay attention to what you're given so that you know what operation to perform. Okay, so in this case, we what's missing is one of the remote interior angles, and I'm given the exterior angle. And so I know that the measure of angle X plus the 45-degree angle have to add up to 129 degrees. And so in order to find the measure of angle X, I'm going to take the 129 and subtract 45, and that will tell me what should go here. So the measure of angle X is 84 degrees. Right there. Okay, you are going to do exercises 5 through 10 independently, and then you can come back and check your solutions against the video. So go ahead and pause now and work on exercises 5 through 10. Notice that in each of these cases, you're not only finding the measure of angle X, but you're also going to present an informal argument showing that your answer is correct. So you can't just give me the number. You want to tell me why it's true. And when you present these informal arguments, you're going to use the angle sum theorem and the fact that a straight angle is 180 degrees. So work on those and come back and check your answers. And if you want to check them one at a time, that's fine. Okay, so here's the result for exercise 5. If I add, I'm asked to find this exterior angle here, angle X, and the measure of that. And so I'm going to add the remote interior angles and get 117. 89 plus 28 is 117. And so I know that the measure of angle X is 117. So my argument for somebody who wants to know why that's true would be to say that the sum of the interior angles is 180. So this angle ACB would need to be 63 degrees so that all three of these angles added up to 180. So I took 180 minus the 117 to get that. The straight angle, and excuse my iPad pen, the straight angle containing angle X, so this straight angle here is also 180 degrees, so the measure of angle X would have to be 180 minus the 63, which would give me the 117. So this is my informal argument, and you should have something similar to that. Maybe not exactly the same words, but expressing the same thought. Okay, so now we can look at exercise 6. If you haven't done it yet, you can pause again. Here's the result for exercise 6. The measure of angle X is 111 degrees, right there. And my argument is that the sum of the interior angles, once again, of the triangle is 180. So the measure of angle BAC would be 180 minus the sum of the other two angles. So it would be 69 degrees. And since the straight angle here is 180 degrees, the measure of angle X is 111. All right, let's look at exercise 7. So let's look at the results for exercise 7 and 8. So for exercise 7, the measure of angle X is 101 degrees. Our informal argument in this case is a little bit simpler because we didn't even need to use this angle, right? Because we already know that this straight angle is going to be 180 degrees, and since straight angles have a measure of 180 degrees, the measure of angle X plus 79 would have to equal 180 degrees. Where's my degrees? There we go. So the measure of angle X would be 101 degrees, 180 minus 79. Okay, let's look at number 8. Number 8 again gets back to using the remote interior angles, and I take the sum of those is 145, and that will be the measure of angle X. My argument here is again going to be, if I want to find the measure of this angle ACB, I'm going to find that that is 35 degrees, because these three angles have to add up to 180. So my measure of angle X is going to be 180 minus 35, which is 145. Okay, so I abbreviated my argument and just gave it verbally. You should practice having that in writing. Okay, we've got two more, so let's look at those now. Okay, so for number 9, the measure of angle X is 107 plus 32. And again, this is the same as, which would be 139. And this is going to be the same argument as the others, where we have the exterior angle, X, adding up to the sum of the remote interior angles. So same arguments there. I'm going to spare you the details, but you need to be responsible for knowing how to present that argument. Okay, let's look at our last example. Okay, so here it is, the last exercise in our classroom portion is exercise 10. The measure of angle X in this diagram right here would be this exterior angle minus angle ABC, which is 81 degrees. So this would be 75 degrees. So let's look at the argument for that. So I'm going to, if you haven't done it yet, you should do it. Pause and I will write it out here. Okay, so we'll talk through the argument for the informal argument for number 10. Measure of angle BAC, right here, this angle, is 24 degrees because it's going to be 180 minus the 156. And so that's 24 degrees because straight angles measure 180. So here's our straight angle there. Also, the measure of angle X plus the other two angles in that triangle, which are 81, and now we know this is 24, have to add up to 180 because the interior angles of a triangle add to 180. So the measure of angle X is 180 minus the sum of the other two angles, which would be 180 minus 81 plus 24, which would be 75 degrees. Okay, so let's look at our lesson summary now on your problem set page. So in this lesson we saw that proof of that other proof as to why well, that didn't come out very well, why the angles of a why the sum of the angles of a triangle are 180 degrees, and we use the quadrilateral, and this won't let me draw a line here for some reason, and we divided it into two congruent triangles and showed that since the rectangle had angles summing to 360, that the triangles had to be half of that, or 180. Okay, so we looked at that. And we also, this picture keeps going away, we also learned definitions of exterior angles, and that's where we extend the line of a triangle out and look at the angle that's right outside the triangle, and each triangle is going to have 3 different exterior angles. And we defined the remote interior angles as the 2 interior angles in the triangle that are not touching a given exterior angle. So for this one, these two angles would be the remote interior angles. And then we saw that it's kind of a shortcut if we want to know the measure of the exterior angle. Instead of having to subtract from 180, we can just add the two remote interior angles, and they're going to add up to that exterior angle. So that was the big idea here. And so your problem set is going to focus on these angle relationships and presenting informal arguments to show that your answer is correct. All right, so that was lesson 14. After lesson 14, you're ready for the mid-module assessment. We're going to do lessons 15 and 16, which are going to be a proof of the Pythagorean theorem, but none of that will be on, I'm talking about the end of module assessment. None of that will be on the end of module assessment. So once you've completed lesson 14, you can either go on and do 15 and 16 and then do your end of module assessment, or you can do the end of module assessment right away. Okay, good luck with all of this, and we'll see you back for Pythagorean theorem.